Welcome to qnawire.
So this problem tells us that we have RbI, and letter A wants us to find the edge length. And so the edge length for a NaCl type structure is A equals F over radical 2, and F equals 4R over radical 2. So we just take 4R over radical 2 over radical 2. And our R in this case is 2.20 angstroms. And so that equals 4.40 angstroms. And so now that we have this, we can move on to letter B. So this is our edge length. Now we can move on to letter B. And the first thing we want to do is find the volume, which is A cubed. And so 4.4 times 10 to the negative 8th centimeters, just converting angstroms to centimeters cubed, equals 8.52 times 10 to the negative 23rd centimeter cubed. And so now we can find our mass. And so our mass is going to be 4 times 212.3723 grams per mole. And the 4 is because it is a NaCl type structure, and then the molar mass of RbI. And then we divide by Avogadro's number. And that gives us 1.4106 times 10 to the negative 21st grams. So now for our density, we just take our number of grams divided by our number of centimeter cubed. And that gives us our density of 16.56 grams per centimeter cubed. And that is our answer for letter B. Now moving on to letter C, now we have a body-centered cubic under high pressure. And so the edge length A is equal to 4 times the radius over radical 3. Our radius is 1.52 angstroms divided by radical 3, and so we get 3.51 angstroms as our edge length. Now that we have that, we can move on to finding the density. And so volume equals A cubed, 3.51 times 10 to the negative 8th cubed, and this is centimeters, equals 4.33 times 10 to the negative 23rd centimeter cubed. So now we can find our mass again. This time we have 2 times 212.3723 grams per mole divided by Avogadro's number. And that gives us that we have 7.053 times 10 to the negative 22nd grams. So again, to find the density, we take our grams divided by our centimeter cubed. And we get that our density is 16.29 grams per centimeter cubed, which is very similar to our density from letter B.